right, so on to our next problem. It states nickel 2 oxide and lithium phosphate are mixed to form nickel phosphate and lithium oxide. It asks us how many grams of nickel 2 phosphate form from the reaction of 5 grams of nickel oxide and 5 grams of lithium phosphate. It also asks us what is the limiting reactant in this reaction and to calculate the percent yield for the reaction, assuming 7.00 grams of nickel 2 phosphate form. So before I look at those questions, I'm going to go ahead and write down the equation. So it gives us the charge of nickel as positive 2. And on our periodic table, we see that oxygen is negative 2. So this ionic compound actually balances itself out perfectly. And we know that most ionic compounds are solid compounds. All right, so moving on to our lithium phosphate. We know that lithium has a charge of positive 1, as it is in column 1, and phosphate is PO4 negative 3. So we are going to have to do a swap and drop on this one. We don't need these parentheses. And again, it is ionic, so we're going to consider it a solid. So those are going to be our reactants. And then for our products, we also want to make sure that these are canceling each other out. So nickel, again, has a positive 2 charge. Phosphate has this negative 3. So I'm going to go ahead and copy and paste that here. So we are going to do a swap and drop here as well. So Ni3, this time the phosphate will go into parentheses. We will do times 2 on that. We also have lithium oxide. Again, we have our lithium as a positive 1 and oxygen as a negative 2. So again, swap and drop. And we want to make sure that we are remembering to, again, write the states of the matter. So solid and solid, since these are all ionic compounds. Okay, so I'm going to go ahead and count these up on each side, and then we can start balancing. Okay, so as you can see, I've counted up all of them. One thing that I do think is helpful is keeping the polyatomic ion together instead of separating it, which is why there's an oxygen here and here. So first of all, I think that the easiest object to balance is going to be the lithium. And something that can be helpful is timesing it kind of by itself. So I'm going to go ahead and put a 2 in front of this lithium so that I get 6. And then this phosphate will become 8, which also balances it over here. And then I'm going to go ahead and times this lithium 3. So there we get 6, and that oxygen also moves to 3, which should be fairly easy to balance because we have nickel and oxygen over here by themselves. So I'm just going to go ahead and put a 3 in front of that as well. So now we have our balanced equation. Okay, so now we are going to create two roadmaps. So we are looking for the grams of nickel phosphate. So first we're going to want to take nickel oxide and put it in 2 grams, since we are given 5.00 grams of nickel oxide. And I'm going to write down both of these that we are looking for, just so that we have them organized. So I'm going to go ahead and do the lithium phosphate really quick as well. All right, now that both of those are written down, so our roadmap is going to go grams to moles, and we'll add a little grams, put R for the reactant, 2 moles of the reactant, 2 moles, we'll just say product, 2 grams of product. So starting off, we're going to go ahead and do our nickel oxide first. And to convert this into moles, we are going to go ahead and have to convert the molar mass. All right, so I calculated that out as 74.69 grams. And again, we're going to use our units in 1 mole of NiO. Next, to get this into our moles of the product of the nickel phosphate, we are going to use the ratio that we can find in our equation. So in our equation, we have 3 moles of nickel oxide. And we only have 1 mole of nickel phosphate. All right, so as you can see, I added moles of nickel phosphate down there, so that can cancel out. And our last step is to find the molar mass of nickel phosphate. So I got 366.01 grams of nickel phosphate. So I'm going to go ahead and do this whole equation. All right, so 8.167 grams of nickel phosphate has been produced from nickel oxide. So I am going to go ahead and set up our next problem as well. Okay, so I just quickly calculated the molar mass of the lithium phosphate. And now we're going to refer back to our balanced chemical equation to get this into moles of nickel phosphate. So we have 2 moles of lithium phosphate in our equation, and we have 1 mole of nickel phosphate in our equation. So I'm going to go ahead and copy and paste this down here. And then same as above, we're going to go ahead and use the molar mass of nickel phosphate to go ahead and cancel this out. So I will go ahead and calculate this really quick. All right. So the answer to this one is 7.90. Again, using the correct sig figs. So 1, 2, 3, just like the 3 figs in the question. And then we're going to put our nickel phosphate, obviously, as a unit beside it. So this will be our theoretical yield and our limiting reactant in this scenario. Moving on to our last step, we're going to do it up here in the free space. We are going to take the actual yield, which is 7.00 grams of nickel phosphate. And we are going to divide it by the theoretical yield of 7.90 grams of nickel phosphate. And then times it by 100 to get our percent yield. Again, still making sure we are watching our sig figs. We get 88.6% yield. Let's just make sure that we have space for that. And of course, using our units at the end. So 88.6% is the percent yield for this reaction. And that is it. Hope you enjoyed.